Hi, everybody. This is Miss Mac. Hope you all had a great Thanksgiving break and looking forward to the next few weeks working with you on inequalities and some other things. I'm going to warn you that this video, I'm covering a lot of things, so I'm going to give you a good spot to take a break if you need to partway through this. So just be listening. And if you need to pause it and go get a drink or go to the bathroom or get a snack or just walk for a second, that is perfectly fine. So what we're going to be doing is we're going to be graphing linear inequalities. So we already graphed linear equations. We did lines, y equals mx plus b. Now we're going to do inequalities. So what I'd like to do is kind of tie this to some things that we've already learned to show you how they're related and how we're expanding. So the first thing I want to do here is I want to take you way back to elementary school. So if I ask you to graph something like x equals 3, basically what you're doing is you're asking yourself, what number can I fill in here for x to make that true? The only number that makes sense is 3. 3 is equal to 3. So what we did on a number line is we learned how to just put a dot right on 3. That means that's my solution. Now, what happens then is after we get past equations, equal signs, we talk about inequality. So these next two on here, greater than or equal to and greater than, have different looking graphs. So if I ask you to look at the next one, greater than or equal to 3, remember when you're filling in a number for x, it can be any number greater than 3 or also equal to 3. So if I ask you what numbers work, you would say, oh, Ms. Mac, 3 works because 3 is equal to 3. 4 also works because 4 is greater than 3. Remember, it can be either one. Basically, any number 3 or larger works. Because 3 works, we use a filled in dot. And because it can be anything larger, it's an arrow to the right. The next one, which is just greater than 3, x is greater than 3. If I ask you what number to fill in, you say, Miss Mac, 3 doesn't work because it's equal to it. But a number like 3.1 would work, or 3.2, or 5, or 9, or 100. Anything larger than 3. But 3 itself does not work. So the difference here is we use this open circle, an open dot, open point, to mean it doesn't work, but it's kind of the cutoff. It's the end for everything that does work and doesn't work. It's a separator. So anything to the right of that works, anything to the left of it doesn't. The same kind of thing happens with less than or equal to's and less thans. So when you're graphing inequalities, they're different than graphing equations. And that difference between the filled in dot and the open dot are going to come up again when we're graphing linear inequalities. So let's kind of do a review of something else that we've already done. So we know that we have been graphing linear equations. We spent weeks on them. So this right here is a linear equation. If I ask you to graph it, you know you need the slope, which is 2, the y-intercept is 1, negative 1. So you notice that over here, that's exactly what I did. I went down to negative 1, up 2 over 1, up to right 1, up to right 1, same thing down and left. And then we drew a line. Basically what this means is that any point on this line, any point on the line, so this is the point 0, negative 1. This is the point 1, 1. This is the point 2, 3. I could pick any point on the line, even the ones that are in between, if I knew what the coordinates are, and they are solutions of this equation. For instance, if I put 2 in for x and 3 in for y, this is what I would get. And I know that 3 is equal to 4 minus 1. That's true. That's a solution. And that would be the case with any point at all on this line. So all of the points on the line are solutions. If I pick any point that is not on the line, it is not a solution. That's the meaning of the graph. That's why this works. That's how it works. So what we're going to do is we are going to learn how to graph things that look like this. So notice they're very similar. They all have the y and the 2x minus 1, but some of them have greater thans, less thans, greater than or equal to's, and the graphs all have a line, solid or dotted, along with shading. So we're going to talk about how you do that and also what these graphs mean. So now would be a great time if you want to take a minute or two or five to take a break, stretch, get a drink, go to the bathroom, hug your dog, whatever it is you want to do, that would be fine. So I'll wait here just a second and I will get back with you then. All righty. I am going to go on to the next example. So we're actually going to graph two inequalities that are going to look very similar in terms of the way they're set up, but the graphs themselves will be very different. I'm going to demonstrate how you do this. So when you graph inequalities, you have three basic rules, or I guess steps. The first one is we have to graph what we call the boundary line. The second step is to decide if the line is going to be solid or dotted. And the third step is to shade the true side of the inequality. So when I look at this inequality, the first thing I notice is that's in slope-intercept form, and it has this greater than or equal to in it. So what I'm going to do is I'm going to start by graphing what I call the boundary line. It is this exact equation or inequality, only putting an equal sign in it. So instead of greater than or equal to, I'm just going to put equal to in here. So I call this the boundary line because it's going to separate points that work as our solution from points that don't. Now, if I go ahead and I graph this, I know my slope is -1/2 and my y-intercept is 3. So I'll go up to 3, then I go down 1, right 2, down 1, right 2, down 1, right 2, up and left 2. And that's where my boundary line is going to be. The second thing I have to do is decide if this is going to be a solid line or a dotted line. So what you need to know is that if you have an equal to in your sign, you are going to have a solid line. If you just have a less than or greater than, it's going to be dotted, or we can also call that a dashed line. So in this case, because we have greater than or equal to, we are going to have a solid line. So I'm going to start by drawing that. Now, that line, remember, I called it a boundary line. So it is separating points that work from points that don't work. And remember, a solid dot on those first inequalities meant that that number, that 3, was a solution. Likewise, a solid line here means the points on the line are solutions. If this was dotted, it would mean they are not solutions. So the third step is we have to do some shading. So we have to shade what we call the true side. So we are going to find what I call a test point. So what I'm going to do is pick a point that is definitely on one side or the other of this line. And I also want to pick something that's easy to calculate with. So I am a big fan of using 0, 0 as my test point if it's not on the line. So what I'm going to do is take 0, 0 and plug it back into the original problem to see if it makes this inequality true or false. So 0's going in for x and 0's going in for y. And I get down to the end where I have 0 is greater than or equal to 3. Now that is a false statement. So because that is false, that means 0, 0 is not a part of our solution. So because this 0, 0 here is not part of the solution, that means any other point on this side of the line is also not a solution. If I were to test any point on that side of the line into the original inequality, it would not be true. So what I'm going to do then is I'm going to shade the other side. The shading represents the solution. So I'm going to come over here and I'm just going to shade this. What that shading means is that any point in that area is a solution. So if I were to pick this point and test it in the problem, or this one, any of those would make the inequality true. They would make it work. So again, basically what this is doing is the shading and the line tell you where the solution is. The solid line means the points on the line are actual solutions to the graph, to the inequality, and the shaded area is also all of the solutions. The unshaded area is not a solution. So let's look at another example. So if you notice, this problem has the same slope and y-intercept, but it has a different inequality. This one is just less than. So first step, graph the boundary line. So again, it's going to be y equals -1/2 x plus 3. I'm going to go up to 3 and then use my slope. And in this case, I have to decide if it's solid or dotted. Now, remember I said if it has an equal to, it's solid, meaning the points on the line work. If it's just less than or greater than, it is dotted or dashed, and that means the points on the line do not work as part of the solution. So because this is just a less than, I'm going to make a dotted line. Okay, I always extend it through the graph. The third step is to shade the true side. So again, I'm going to pick a test point. And remember, I said I like to pick 0, 0 because it's so nice to work with. But if your line goes through 0, 0, you can't use that. So I'm going to put 0, 0 back into the original problem. And I'm left with 0 is less than 3. That, my friends, is a true statement. So that means 0, 0, which is right here, made the inequality true. That means that any point on this side of the line with 0, 0 is going to be a solution. So we shade this side of the line. So as a recap, any point on this side in the shaded area is a solution. If I pick any point over here in the unshaded area, it is not a solution. If I pick a point on the line because it's a dashed or dotted line, it is not a solution. All right, so here we go. In order to graph a linear inequality, we need to remember there are 3 steps. The first one is graph the boundary line. Second, decide if it's solid or dotted. And the third is to shade the true side. Now, down here, we have a little key. So if it is less than or equal to, greater than or equal to, you are going to have a solid line. And if that's the case, the points on the line are solutions. I should say points on the line are solutions. So if I had points on here, they are solutions. If I come over to this one and I pick points on the line, so I would say points on the line are not solutions. So that's really important to remember. And we're going to follow up with just 2 more quick questions kind of relating to this. So I could ask you to do a couple different things. I could ask you to do the whole process like we did before, or I could ask you to do this. So if you notice, we have the same inequality here and here. And if you notice, we have the same points listed with each one. The first part of this says algebraically determine whether or not each ordered pair is a solution of the inequality. Down at the bottom, it says use the graph to determine whether or not each ordered pair is a solution of the inequality. So if we start with the top, the only way to algebraically determine this is to actually plug in x and y and do some calculating. So I'm going to do that for each one of these. So I'm just plugging the numbers into the inequality. I get 5 is greater than -2. That is true. So that means this is a solution. Okay, if I do the next one and I plug these in, So 1 is going in for y, 0 is going in for x. 1 is greater than 4. That is false. Because it is false, that means that this ordered pair is not a solution. Okay? Then lastly, -1, 6. 6 is greater than 6. So that's close. They're equal, but it is not greater than. So again, this is false. Because it is false, that means that this ordered pair is not a solution. Okay, so algebraically, that's how you determine solution or not. Now down here, it's pretty quick once you have a graph. So if I look at the point 3,5 over here, 3,5, if you notice, it's in the shaded part. Well, remember, the shaded part is where the solutions are. So because it's in the shaded part, that means it is a solution. 0, 1 is the ordered pair right here. It's in the unshaded part, so that means it is not a solution. And then -1, 6, if you notice, it's way up here. It's on the line, but that's a dotted line or a dashed line. On a dotted line is not a solution. If it was a solid line, it would be. Dotted line, it is not. So right there is how you graph linear inequalities. Make sure if you have questions, you reach out to your teacher or to me, Miss Mack. You can always send me an email. It's Mrs. McElroy. Don't hesitate to ask if you need some help, and please don't get behind on any of these assignments because it gets hard to get caught up. Remember, we only have a few weeks till the end of the semester, and we want everyone to finish strong. Thanks. Have a great day. Bye-bye.